Okay, on this page we are applying what we know about the binomial expansion, but we're also paying attention to this terminology. These words like term and variable and coefficient are going to come into things. Okay, and part of the moral here, okay, we're going to be using I must, so that's how we write. We also have to read carefully. So this word ascending is important. It means that the powers of x have to be increasing. So we know that we're going to do something to the power of 9, and the binomial expansion, the bracket structure is we're going to get a bracket to the power of 9, and then the remaining terms until the very last one will be a tall bracket times the two brackets. The powers of the first one go down to by 1 each time, so 9 then 8. First bracket, the second bracket starts at 1 in this term, and then we get a tall bracket, 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 we get a tall bracket, 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 and the powers of the first one are going to go down to 7 and then down to 6, and the other one are going to go 1 and then 2 and then 3, and those are going to be my first 4 terms. Okay, but I need to make sure that it's ascending powers of x. So that means I need the powers of x to start small and get bigger. So it might have been that I'd have to change the order of these terms. If the 2x had been first, then I'd have started with 2x in the bracket to the power of 9, which is the biggest power of x. These are actually the right way round. So we are going to look at minus y plus 2x to the power of 9, and so the first the first bracket is going to be minus y, and all the copies of that bracket are going to have minus y in them. Really important, it's minus y, not y, because the minus is going to be raised to powers as well. And for the other bracket it's 2x, and it's really important that the 2 is inside the brackets, because the 2 is going to be raised to the powers. That's why the bracket structure is so important. And then the formula book tells you that these coefficients are n choose 1, n choose 2. So my n is 9, so this is 9 choose 1 and 9 choose 2. And this is 9 choose 3, and that is for the first 4 terms. And ascending, the first term has got x to the power of 0, and the powers of x go up, just like I want what I want. So in I must, I've identified, I've got a method from the bracket structure, and I've got a correct unsimplified answer. So I'm nearly there. I've just got to simplify it. But we don't try and simplify in one line. We simplify it across 2 lines, because there's quite a lot going on in each term. So the powers of minus y, clearly to the power of 9, I'm going to get a y to the power of 9, but a minus y to the power of 9, because 9 is odd, I've got 9 negative numbers being multiplied together, and that's going to give a negative answer, because there's an odd number of negative numbers being multiplied together. Whereas in the second term, 9 choose 1, your calculator will tell you is 9, dot means times. And then the minus y to the power of 8, 8 is an even power, so I've got an even power of a negative number, so that's going to be just y to the power of 8, because minus 1 times itself 8 times over comes back to equaling plus 1, because 8 is even. And 2x to the power of 1 is just 2x. And I do the same thing for the remaining 2 terms. So when I do minus y to the power of 7 and it's negative, I need to keep those brackets so it doesn't look like a subtraction. And when I do powers of 2x, because the 2 is inside the brackets, the 2 gets squared to 4 and the 2 gets cubed to 8 here. Okay, so there's quite a lot going on. Do not try and skip this step. Now I'm ready to let my calculator take care of the numbers, so I can use my calculator if I need to for 9 times 2. So the first term is obviously minus y to the power of 9. 9 times 2 is 18, and then I've got y to the power of 8x. And then I've got 36 times 4, your calculator will tell you is 144. Oh, times minus y to the 7 times x squared. So I'm going to get y to the 7, I'm going to get x squared, but that minus means that the overall term is negative, so I can change that to a minus. Okay, and then the last term, 84 times 8, you can do on your calculator. And there we go. So those are the correct stepping stones. We've done a simplified answer. So the last step of I must is to terminate. So we double underline, having checked that we have got exactly what we were asked for. 4 terms. Yes, I've done that. They are ascending powers of x. Always go back and make sure you answered the question you were asked. Okay, question 2.4. Okay, we've got an expansion to do here. Now we want a term containing a specific thing. So if we identify what we're looking at, we could identify that we're looking at 2 plus 3y to the power of 7. Now the complete expansion of that would have the complete bracket structure. which would start out with bracket to the power of 7, and then we'd have one of these, and then we'd have more ones with a tall bracket and two smaller brackets. Now, I'm only interested actually in one term, so I don't have to fill all of this in. I mean, you can do. If you're most confident just filling it all the way in, then that's fine. But we want the term where we're going to get y cubed. So if we do it in this order, my y's are going to appear in the second bracket. So this one here would have 3y to the power of 1. So I can work out that it would be actually this term that will have 3y to the power of 3. So it's only this term that I need to fill in. So these are optional. Whether you put them down, whether they help you or not, is up to you. If you do want to go straight to this, you may find it helpful to look at the general term from the formula book. So here is the formula we're using in its place in the formula book, and this bit here is the general term. So you can work out that if you want b to the power of r, then you need to have n choose r, and the power of a you need is n minus r. So for this term here, I want a power of 3, so like my r is 3, so I need a 3 here, so this needs to be 7 choose 3, and the power of 2 that I'm going to need, so the first term here is 2, that power is going to be n minus r is 7 minus 3, which is 4. So I can get straight to that term without having filled these ones in, if that's what I want to do. So I now need to identify again, because I'm only interested in the particular term with the y cubed. So the y cubed term equals, okay, and then I just need to do these three things. So 7 choose 3. Okay, and then having simplified separately the three stages, we can get our calculator to do that calculation. And we get this, okay? And then we need to terminate, and we need to pick up on the language. We want a term, and this is indeed the full term. If it had asked for the coefficient, that would just be the number in front of our variable y cubed. Okay. Oh, hang on, we're reading the question. We've got to state the coefficient as well. So there are two answers. Find the term. So I need to double underline this. Okay. But I also need to state the coefficient. So there it is, and that also needs double underlining. So that business of terminating, I might have forgotten to do the stating the coefficient if I hadn't consciously thought at the end, have I done what I've been asked to do? So that was I must in action again. We're not at all, don't feel at all guilty that this was never filled in. I didn't need it in the first place. If I'm identifying what I'm doing as being the complete expansion, then I suppose I need to acknowledge these terms would be there. But I must is not about doing hugely more work or using stupid ink for stuff you don't need. I don't need to fill those terms in because that's not what I was asked for. And then finally on this page, example 2.5, it's asking for a coefficient, so I'll need to bear that in mind. And I'm doing this expansion again. I've got a bracket to the power of 7, so it's going to start out like this again. Okay, but I can see that this time, if I want to get x to the power of 5, I don't want to write out all of these bits, so I can use the ... to show that I've missed some out. So if I want to be doing x to the power of 5, I'm going to want a power of 5 on that second bracket. This is going to be 7 choose, it's going to have counted its way up to, remember the bottom number here always matches the power, so that's going to be 7 on the second bracket, so that's going to be 7 choose 5, and the power on the first bracket plus the power on the second bracket always add up to 7, so this is going to be a power of 2, or I could turn to the formula book and use that general term. So what do I put in the brackets? I put a k in this one. Careful with this one, this is minus 2x to the power of 5. Okay, so I do the 2 steps of simplification. So here we go, but now I'm only looking at one term, so I need to identify this. I'm now just looking at the x to the power 5 term, and my calculator will do the multiplication. So there's my x to the power 5 term. It's a simplified answer. I've been through unsimplified, but I need to terminate anything of I must. Now the question asked me to find the coefficient, and it also says where k is a constant. Now normally, if we've got something with a mixture of numbers and letters, we might refer to the number part as being the coefficient. But because it's emphasized that k is a constant, therefore x is the variable, the coefficient is the constant that appears in front of our variable. So in fact, in this case, the coefficient has got a letter in it. But it does not have the x to the 5 in it. So the coefficient is just the number that is being multiplied by our variable. So hope that all makes sense.